Okay, so this is the pin diagram of the ESP8266 microcontroller, which is called NodeMCU. In this, you can see that this is the microcontroller that is there. The microcontroller name is ESP8266. This is also enabled with the Wi-Fi module, which is 802.11. Protocol will be applied here with this Wi-Fi component. It means that this particular microcontroller can be connected to the internet through any access point. Okay, so yeah, this is about that. Then we have around 30 pins. This side we have 15 pin and this side we have 15 pin. So if we'll go from here to here, we have some pins like the pin name which is in the board, which is written like it is D0, D1, D2, D3, D4, and then we have D5 here, D6, D7, D8, and yes. So up to D8 pins are there. Then we have another different type of pins. So if we'll start from here, we have 3 voltage. It is written 3.3 voltage. It means that the sensor node, we can give the power supply to some of the sensor node through this voltage, right? Because there are sensors which actually will not take that much of voltage. It will take a small amount of voltage. So from the board, we can give these power to the sensors. Okay, and then we have the ground pin, which will makes your circuit complete with the voltage and the ground. Then we have some special purpose pin like RX and TX pin. RX pin is for receiving any data. So will either we can attach this particular microcontroller with the RF receiver and the sender, or with the Bluetooth receiver and the sender module. So for that, we use this particular pin for the receiving any data, and TX pin for sending any data, as well as you can see here, it is written another name of these pins, that is called GPIO, that is called general purpose input output pin. These general purpose input output pins are there in the manual of NodeMCU. So we can use these pin names also. So all these general purpose input output pins, we can use it for connecting any sensor as well as connecting any actuator. Okay. Then in this particular part, we have ADC, that is analog to digital converter, as well as this is the pin where we can attach any type of analog sensor. So this we can use it for the analog sensor. These two are the reserve pin for any other work other than the work or the functions that is given by the microcontroller. And then we have 2 more general purpose input output pins here, and we have some special purpose pins here, that is master in, slave out. For the serial communication, we'll use it. Then chip selection, master in, slave out. And we have the system clock, that we can use it for the synchronization. Then here also we have ground pin and 3 voltage output pin. We have some reset button here, and we have some EN, that is some enabling button, enabling pin. Then we have the ground pin again, and VIN for the voltage given to this particular board. So we can give the voltage to this particular board with this voltage in pin, as well as we can give the power to it with this particular micro USB pin. So this is the micro USB pin, which will use for giving the power to this particular microcontroller, as well as we can use this for flushing any codes. So we'll put the code in this particular microcontroller so that it will run that particular code. Here we have two different buttons. This is the reset button and this is the flash button. The reset button, if we want to run our program again from the beginning, so we'll use the reset button, and flush button is for flushing the code into that particular microcontroller. So flush button generally we will not use because we just flush the data from this particular micro USB port. Okay. And then you can see here again we have a micro controller which is there. This particular microcontroller will convert your high level language into the lower level language so that the machine can understand that. So this is the structure of this NodeMCU microcontroller that we are going to use. Okay. Now, what are the things that we'll do today is we'll try to mimic one experiment in which we try to control one appliances using the Android application. Okay. So as I have shown you about the structure of the IoT infrastructure, it needs some module. It has some module, okay? And there is the part which is called user interface. Through the user interface, actually, user can get the data from the IoT infrastructure through the cloud, or if we are not using the cloud, then we have some in between some server which can work as a cloud and which can store and process your data and send the data to the user through user interface. So ultimately, why we are using IoT infrastructure? So we generally use IoT infrastructure to monitor the object as well as to control the object remotely, right? Remotely, what is the meaning of remotely is that with the help of internet we can do it. Can we control or can we monitor anything, any object through the internet? So this is the main objective of the IoT, and the analytics, the processing, and all those things are the additional, you can say, the supplement work of the IoT that an IoT will perform. But generally, the IoT infrastructure will make to monitor as well as to control the object. So in the experiment also we'll do the same thing. So first of all, we'll create this network, this thing network, okay? And after making that, we'll try to connect it to the internet, and with the help of any user interface. So we'll create one user interface that is so user interface could be anything, right? It may be your Android application, it may be your web application, it may be through WhatsApp messages we send the data, or through the SMS we send the data, right? So anyway, if we are giving the information of the IoT to the user through the user interface. So first of all, we'll see that how we can create the user interface as the Android application. Second, we'll see that how we can program the microcontroller, and these two we'll see, and then we'll move on to our project. Okay. So let me first go to the coding part, okay, and that how we'll code into the microcontroller, that is NodeMCU. So as I have shown you the structure of the NodeMCU, that NodeMCU has 30 different pins, okay, and all this pin have different usage. So you can see there are the general purpose input output pin that will use for taking the input from the sensor or to giving the signal to the actuator, right? So as I told you, in the experiment, we'll mimic that we are controlling any appliances. Any appliances means anything that you want to control, you can control it, but we'll mimic one appliances that we are controlling. So instead of appliances, I'll use one LED. So that LED we are controlling, we try to control with the help of the application. Okay, so let's go to this is the IDE by which we'll make any program, and that program will upload into the microcontroller. Okay, so as you all have seen, this is the microcontroller that we are going to use. Okay, this is, as I told you, this is NodeMCU, and you can see here, this is the chip that we are talking about. That is a microcontroller 80 ESP 8066. So this is the microcontroller that will use ESP8266, and it is having the Wi-Fi in it inbuilt. And you can see this is the pin for flushing any code, as well as we give the power to this particular pin with this particular microcontroller. And you can see here, these are all different 30 pins that we'll use. Okay. And in the board also you can see that there is pin number also has been written, like D0, D1, D2. All those pin numbers are also there in this particular way, in this particular side, as well as in this side also you can see there are different pin numbers.